differential equations of geodesics. Okay, so what is the differential equation of geodesic? So first we know what is geodesic. So geodesic is a curve of shortest path, means a curve of shortest length is called geodesic. In a plane, geodesic is a straight line. Okay, so I want to explain differential equation of geodesic. So let see that xi is equal to xi of t is a curve in Riemannian space Vn. Okay, we have this is a curve, okay, and these are endpoints A and B. Suppose arc length is S and T is parameter, okay. So this is a curve. Our aim to obtain differential equation of geodesic, okay. So we have geodesic satisfying Lagrange equation. We have geodesic satisfying Lagrange equation. Lagrange equation is also called Euler's equation. Means del phi y del xi minus dy by dt del phi y del x dot I equal to 0. What is phi? Where phi is equal to s dot. S dot means s is arc length and s dot means ds by dt. Okay, s is parameter. Now let us consider the line element of the curve C is ds square is equal to gk dx j dx k. Okay, we have line element means distance between 2 points. Distance between 2 points in Riemannian space Vn is ds square is equal to gij dxj dxi dxj or gjk dxj dxk. Okay, this can also be written means on taking square root. So ds is equal to gjk dx j dx k square root or ds by dt is equal to square root g jk dx j by dt dx k by dt. Okay, or ds by dt is denoted by s dot. Okay, means s dot is equal to g jk dx j y dt dx k y dt square root. Okay, this can also be written as g jk x dot j x dot k, means s dot is equal to gij x dot j x dot k square root. Let phi is equal to s dot. Since phi is equal to s dot, so our aim is to putting the value of del phi upon del xi and del phi upon del x dot I in Euler equation. So first we obtain del phi upon del xi. Okay, so let phi is equal to s dot means this thing g jk x dot j x dot k. Then differentiating partially with respect to xi. Differentiating partially with respect to xi. Okay, means del phi by del xi is equal to differentiation of this thing means formula x to the power n means 1 by 2 this thing power minus half, so g j k x dot j x dot k, and then again del y by del xi g j k x dot j x dot k. Okay, this is s dot, so this can be written as 1 by 2 s dot del gjk del xi. This is constant with respect to xi, so x dot j x dot k. Okay, so this is 2. Now again differentiating here, this is phi is equal to s dot is an equation 1. Now again differentiating with respect to x dot. Okay, means differentiating partially equation 1 with respect to x dot I. Okay, so we get del phi by del x dot I is equal to, here differentiation with respect to x dot I, so here product of two function, but first we differentiate x to the power n formula, so 1 by 2 this thing power minus half, and then differentiation of x dot g and x dot k by product of two function. Okay, so del phi upon del x dot I is equal to 1 by 2, this is s dot, and gjk is constant with respect to dot means gjk, and here del x, first we differentiate del x dot j by del xi x dot k as it is, plus x dot j as it is del x dot k upon del x here dot I. Okay, so this is 1 by 2 s dot gjk. Here this is chronicle delta jk, chronicle delta ji, chronicle delta ji, and x dot k plus x dot j chronicle delta ki. So this is in bracket, so 1 upon 2 s dot gjk. Now multiplying both the terms, so gjk x dot k chronicle delta ji plus gjk x dot j chronicle delta ki. Why the definition of chronicle delta? Since chronicle delta ij is equal to 0 or 1, I not equal to j, so this is 0, I equal to j, so this is 1. Okay, so by definition of chronicle delta, this equal to 1 by 2s dot j is equal to I, here j is equal to I, then this is 1, otherwise 0. So here I, so Gik x dot k plus, here k is equal to y means g j, here I is equal to j means here I k x dot k, okay, and k is equal to y means g I k x dot j, okay, x dot j, since j is k is equal to y. So here gjk x dot j chronicle delta ki. So by definition of chronicle delta, k is equal to y means k is equal to I. Here k is equal to I and this is j. So this is ij, okay. Since j is dummy, so we can change either k is equal to j or here j is equal to k, okay. So here by changing dummy index, k is equal to j, so here k is equal to j, so this is gij 1 by 2 s dot gij x dot j plus gij x dot j. This is 2 times 2 to cancel, so this is equal to 1 by s dot gij x dot j. So this is del phi y del x dot I. This is the third equation. Now substituting the value of del phi upon del xi and del phi upon del x dot I in Euler's equation. Means Euler's equations, as we know, del phi y del x I minus dy by dt del phi y del x dot I equal to 0. Okay, so 1 upon 2s dot del gjk upon del x I x dot j x dot k minus dy by dt. This is 1 by s dot gij x dot j equal to 0. Okay, so here j and k are dummy. Okay, so this can be written as 1 by 2s dot del gjk upon del x I x dot j x dot k. Here differentiation, there are 3 functions. So first we differentiate 1 upon s dot. So this is minus 1 upon s dot square s double dot and gij x dot j as it is. Then this is second function, so plus 1 upon s dot del gij upon del xk dxk by dt and x dot j as it is plus these two as it is 1 upon s dot gij and differentiation of this thing is x double dot j. Okay, this is equal to 0. So this can be written as 1 by 2s dot del gjk upon del x I x dot j x dot k. This is as it is. Okay, and now multiplying minus sign in bracket. Okay, so this is 1 upon s dot square s double dot gij x dot j minus 1 upon s dot del gij upon del xk x dot j x dot k. This is x dot k. Okay, minus 1 upon s dot gij x double dot j is equal to 0. Now multiplying by minus s dot on both the sides. So we get multiplying by minus s dot on both the sides. So we get this term. First we will write this term. So g I j x double dot j plus 1 del g I j upon del x k x dot j x dot k. Okay, this is minus 1 by 2 del g j k upon this term del x I x dot j x dot k minus s double dot upon s dot x dot j g I j is equal to 0. Okay, since we have del g I j upon del x k by the property of Christoffel symbols of first kind, this is equal to I j k plus j k I. Okay, so this can be written as, this is as it is, g I j x double dot j plus, this is the, what is the value by using this formula. So I j k plus j k I, and this thing as it is, x dot j x dot k minus 1 by 2, again by the formula of this thing, j k I plus k j I. Okay, x dot j x dot k, this thing, and then remaining things means gij, this thing, and minus s double dot upon s dot g x dot j g I j is equal to 0. Okay, this can be written as g I j x double dot j plus I j k plus j k I x dot j x dot k minus j k I x dot j x dot k minus s double dot upon s dot x dot j g I j is equal to 0. Okay, so by the property of Christoffel symbols of first kind means this should be cancelled. Okay, so this is x double dot j g I j plus only this term, so I j k x dot j x dot k minus s double dot upon s dot x dot j g I j is equal to 0. Now multiplying by GIL. So by multiplying by GIL, x double dot j gij GIL plus IJK GIL x dot j x dot k minus s double dot by s dot x dot j gij GIL is equal to 0. By the definition of chronicle delta, this is I contract and then chronicle delta LJ. Chronicle delta LJ x double dot j plus here by definition of Christoffel symbol of second kind, this is Christoffel symbol of second kind L J K x dot j x dot k minus again by definition of chronicle delta j I contract, this is Lj chronicle delta Lj and s double dot upon s dot x dot j is equal to 0. Okay, by the definition of chronicle delta L is equal to j, so this is 1, otherwise 0. So x double dot L plus Christoffel symbol of second kind means gamma Ljk x dot j x dot k minus again by definition of chronicle delta L is equal to j then 1, otherwise 0. So here s double dot upon s dot x dot L is equal to 0. We choose s as parameter such that s is equal to t, then s dot means ds by dt is equal to 1 and s double dot is equal to 0. So putting the value of s is equal to t, then we get x double dot L plus gamma Ljk x dot j x dot k, this is 0, so this is equal to 0. Okay, so this can also be written as d2x L by dt2 plus gamma Ljk dx j by dt dx k by dt equal to 0. So this is called geodesic differential equation, which is very important in Riemannian geometry also for the geodesic. Okay, so this is a geodesic differential equation.